Hello friends and welcome to another tutorial on GeeksforGeeks. In this video, we are going to understand the program which checks if two BSTs contain the same set of elements. First, let us take an example. The above two binary search trees contain the same set of elements which are 5, 10, 12, 15, 20 and 25. Now, let us see the algorithm. We know about an interesting property of binary search tree that in-order traversal of a BST generates a sorted array. So, we can do in-order traversals of both the BSTs and generate two arrays. Then we can compare these two arrays. If both the arrays are same, then the BSTs have same set of elements, otherwise not. Let us also have sample trees to test our algorithm. We pass the root nodes of both the trees to checkBSTs function. So, root 1 will point to 7 and root 2 will point to 5. The first two if conditions are not satisfied, and then we create two vectors v1 and v2. Then we call the storeInOrder function with root 1 and v1 passed as parameters. So, in the storeInOrder function, root will point to 7. Since root is not null, we pass the left child of 7 using a called stack. Again, as root is not null, we further pass the left child of 5, which is 4. Again, root is not null, so we pass the left child of 4, which is null. Now, as root points to null, we return to the call stack and resume execution for node 4. We push 4 into the vector v. The right child of 4 is also null, so we return and finish execution for node 4. Execution for node 5 is resumed, and now we push node 5 into the vector. Next, we pass the right child of 5, which is 6. The left child of 6 is null, so we return and store 6 into the vector. The right child of 6 is null as well, so we return and finish execution for node 6. Execution for node 7 is resumed, and now we push 7 into the vector. Next, we pass the right child of 7, which is 16. As the left child of 16 is null, we return and store 16 in the vector. As the right child of 16 is null, we return and finish execution for node 16. Also, execution for node 7 and node 5 is over, and in the checkBSTs function, vector v1 will have same values as v. Now, we pass the second root and v2 to storeInOrder function, and in the same way as we did before, v2 will have the in-order traversal of the tree with root 5. In the last step, we return true as v1 is identical to v2. Hence, these two trees are identical. Now, let us have a look at the time complexity of the program. This code will run in big O of n complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.